How does local buckling reduce thin plate structural capacity? Imagine a thin sheet of metal in a building or a bridge. When it faces pressure, it might not just bend smoothly. Instead, tiny ripples or waves can suddenly appear. This is called local buckling. It happens when parts of the thin plate deform out of their original flat shape under compression. These ripples are small but can cause big problems. They make the plate weaker because they reduce the area that can carry the load. Instead of supporting weight evenly, the buckled area becomes less effective. This means the entire structure can become unstable earlier than expected. The critical point where buckling starts depends on several things. Thinner plates with a high width-to-thickness ratio are more likely to buckle at lower stresses. If the edges of the plate are supported along only one side, it becomes even more vulnerable. When the compressive force reaches this critical level, the plate begins to wrinkle or bend locally. Once buckling occurs, the load it can support drops sharply. This is because the effective cross-sectional area resisting the force is now smaller. In many structures, especially those made with cold-formed steel or thin-walled sections, local buckling happens before the steel actually yields or fractures. This means the failure is caused by instability, not the material breaking apart. Sometimes, after buckling, the structure can still hold some load in a stable way. But the initial buckling already limits how much weight the structure can safely carry. Engineers need to consider local buckling when designing thin plates. They often use methods to account for the reduced cross-sectional area after buckling, or reinforce the plates to delay the onset. Ignoring this failure mode can lead to unexpected collapse at lower loads. This is why understanding how local buckling works is so important in making safe, reliable structures. It reduces the overall capacity by causing early deformation and instability in slender, thin plates. That's why high slenderness ratios in thin plates demand careful analysis and sometimes additional support to prevent buckling from happening too soon.